Let's take a look at this example of finding the slope of a tangent line uh, when the function that we're looking at is a rational function. So here we have it. It says find the slope of the line tangent to the graph of f of x equals 1 over x minus 2, a rational function, at the point where x is equal to c. Okay? Well, what we have is we have the ordered pair c comma f of c, and the f of c is going to be 1 over c minus 2. We have that ordered pair as my point of tangency. Point of tangency. So I'm going to choose another arbitrary point where the x value is x and the y value is 1 over that arbitrary x value minus 2. So I'm going to allow this point here to get arbitrarily close to this point of tangency. As this point gets closer to this point, the secant line connecting these 2 points will become closer and closer to the tangent line at this point right here. So let's go ahead and do it here. So to find the slope of the tangent line, what I need to do is take the limit as x approaches c. I want the x value here to get closer to the x value here. So x itself is approaching c. I want the limit as x approaches c of, and now I'm going to find the slope of the secant line connecting those 2 points. That is going to be 1 over x minus 2, or y2, minus 1 over c minus 2, or y1, divided by x, or x2 minus c, or x1. Okay, so we have this limit that we need to find, and when we find this limit, we will have found the slope of the tangent line to the curve. Well, upon direct substitution of c for x, this becomes 1 over c minus 2 minus 1 over c minus 2, which would be 0, over c minus c, which is also 0. So I get 0 over 0, the indeterminate form. So I need to find a way to cancel out the factor x minus c so that it doesn't create a 0 on the top and on the bottom. And now the way that I'm going to do that is I'm going to go ahead and I'm going to simplify this complex fraction. It's a complex fraction because I have a difference of 2 fractions in the numerator of another fraction. So what I want to do is I want to find this difference. I want to subtract these two, and then I'm going to take that single fraction I get for the answer and divide it by x minus c. So we have the limit as x approaches c, and the common denominator here, the least common denominator of those 2 fractions in the numerator, is the product of their denominators, x minus 2 times c minus 2. That is the least common denominator. The first fraction, 1 over x minus 2, is missing one of those factors. It's missing the factor of c minus 2, so I multiply that factor into its numerator and its denominator. I'm multiplying it into both because I can't multiply it into the denominator without also multiplying it into the numerator. All right, so that is an equivalent fraction for this fraction right here. Then we'll have minus, and now I'm going to take this 1 over c minus 2. Well, 1 over c minus 2, I'm also going to multiply by the factor that's missing in that fraction, and the missing factor is actually the factor x minus 2. So the LCD has a factor of c minus 2, but it also has that x minus 2 factor, which is missing from this fraction, so I just multiply it in. To multiply it into the denominator, so I can have a common denominator, I also have to multiply it into the numerator. And then we still have x minus c in the bottom here. All right, so now I have a common denominator for the 2 fractions in my numerator. The common denominator is the product of x minus 2 and c minus 2. So I'm going to keep that denominator, x minus 2 comma c minus 2. I'm going to keep that denominator. And now the numerator, well, the first term in the numerator is going to be c minus 2 times 1, which is just c minus 2. Then I'll have minus, the second term is going to be 1 times x minus 2, which is just x minus 2. I put that in parentheses because I have to subtract it and it's a binomial. This is all still divided by x minus c, and I'm still taking the limit as x approaches c. So I get this thing. All right, so now what I want to do is I want to go ahead and distribute that negative and combine like terms in the numerator. So I'll have x minus 2 minus x plus 2. Uh, Oops, not x minus 2, that's a c. So sorry, I'll have c minus 2, c minus 2, minus x, and then plus 2, all divided by x minus 2 times c minus 2, and that's all still divided by x minus c. All right, so what happens in the numerator is that the negative 2 and the positive 2 cancel each other out, leaving me the limit as x approaches c of c minus x over x minus 2 times c minus 2, and this is all still divided by x minus c. Okay, so now I'm going to take the fraction in the denominator, which the fraction in the denominator is this, x minus c divided by 1. I'm going to flip that fraction over and multiply by it. So I'm going to have the limit as x approaches c of c minus x over x minus 2 times c minus 2 multiplied by the reciprocal of this fraction in the denominator, which is 1 over x minus c. And now I see I can almost cancel that factor of x minus c that I was looking to cancel, the factor that makes the numerator and the denominator 0. The only thing I have to do is factor a negative 1 out of one of these two factors because they're opposites right now, but I can always pull out the extra factor of negative 1 out of this top fraction, for instance, or the top factor c minus x, for instance. And when you factor negative 1 from c minus x, it becomes negative 1 times x minus c. This is divided by x minus 2 times c minus 2, and still multiplied by 1 over x minus c. Now my factor x minus c here cancels my factor x minus c here, and I get the limit as x approaches c, and I'm going to find this product. Negative 1 times positive 1 is the numerator, that's negative 1. And the denominator is x minus 2 multiplied by c minus 2. And now I'm ready to, since I've canceled out that factor that caused the numerator and denominator to be 0, now I'm ready to plug in c for x again, because x is approaching c. So the limit as x approaches c then is going to be negative 1 over c minus 2 times c minus 2, or negative 1 over c minus 2 squared. So this is how you're going to approach those limits that involve rational functions. Whenever the limit involves rational functions, like this one does here, and you get 0 over 0, the indeterminate form, what you're going to do is you're going to simplify the complex fraction by combining the fractions that are in the numerator and the denominator, and then taking the denominator, flipping it, and multiplying it by the numerator. And that should allow you to cancel out the factor that created the 0 over 0, the indeterminate form in the first place, and then you should be able to calculate a limit.